Welcome, everybody, and thank you very, very much for joining us for the second edition of iPHA Q&A with PHI. Today we have Edward Lowes from the Component Certification Department here to discuss what he and the rest of his department get up to, the processes, and also the frequently asked questions. A few aspects on the agenda include this introduction that I'm giving right now, followed by a short presentation from Edward on Passive House component certification, and then we'll have plenty of time for questions and, of course, the answers. Today's session will run for approximately an hour, and it is worth one further education credit point. So for those of you recertifying or looking to gain more experience for your professional certification, the CEF code is below. And you can also always find those codes on the training department's website. Please type your questions into the webinar Jam chat box during today's events. The questions will be collected and then answered after the presentation. And just a heads up, the Q&A is being recorded and it will be made available to everyone after the event. If you registered via Webinar Jam, you'll automatically be sent the recording. And if you didn't or you want to rewatch it later, you can also view it via YouTube. We'll upload this video later this week or early next week. So just a few things about us. I am Georgia, and you can also see on camera below my colleague Carl. Together we manage the International Passive House Association, or iPHA for short. You can always contact us at the email address listed here, or you can check out our website to find out more. We have plenty of different aspects of Passive House information, including running Passipedia and webinars and events like this. We also have infographics, brochures, flyers. We run a blog, we run lots of social media, and just so much to find out. So do check out our website and find out more. And finally, before I pass over, Ed, if you can change to the next slide. We have Edward Lowes, our component certifier for tonight. He is a facade engineer in training. He's very, very much close to graduating, he assures me. But he's actually an architect by background as well. And he's been working at the Passive House Institute since 2015. His work focuses on the certification of opaque and transparent components, and he is a big fan of facades, as his facade engineer training would suggest, and also of windows, as well as other aspects of those components. So he does that all over the world, and he will be telling us much more about it. And I think that other than mentioning that we have another colleague from the Component Certification Department, Soraya, on board tonight, who will be in the chat section answering your questions, I will hand over to the Component Certification Department and specifically to Ed.
Thank you very much, Georgia, for that lively introduction. Yes, welcome once again, everybody, to this evening's Q&A session. It's great to have you here. I'm sorry that we can't all be in the same room together. Perhaps this is something that will happen next year. You never know. So yes, I am Edward. I work on the component certification team, and I am going to cram as much information about component certification into 20 minutes as possible, and then hopefully answer some interesting questions. So let's get going. So component certification in a nutshell. Generally speaking, component certification can be divided into three areas. So transparent, opaque, and HVAC, so heating, ventilation, and air conditioning systems. The purpose of the whole component certification scheme is optimizing the process of energy balance calculation using key values verified by us. So this evening's session is going to focus on transparent and opaque components. I'm going to do my best to give an overview and to answer any questions regarding HVAC systems. But it's not my field of expertise, so any questions that I can't answer will be forwarded onto my colleague, who will be happy to provide a response in the coming days. And I spoke to Georgia earlier, and we thought that if there's a big enough response and enough questions to do with HVAC components, that it would be a possibility to do a separate session on HVAC components at some point in the future. So Component certification is one of 7 key areas of the Passive House Institute's work, the others being building certification and consultancy, so perhaps you saw Corinna presenting last time. Communications, so the International Passive House Association, so this is what Georgia and Carl are doing. Passipedia, so our Passive House Encyclopedia, our knowledge portal. Passive House tools, so the Passive House planning package and design PH software, which many of you will be familiar with. Training and education, so our continuing education department, training up all of the professionals who work in the design and construction of passive houses. And of course, research into new technologies and monitoring of existing technologies underpins pretty much everything that we do. But this session is about component certification, and what we're going to be looking at is what are the benefits of certification, how does it work, and we're going to look at some examples of components that have already been certified. So why do components get certified? What are the benefits from the point of view of a manufacturer? Well, we're very proud that the Passive House Institute logo is a mark of extremely high quality, and this is not just us being arrogant. This is it's something that's simply built into the standard. You have to use very high quality components to achieve the Passive House standard. It also makes Passive House relevant performance data easily available for use in the energy modeling software, so Design PH and PHPP once again. It's quality assurance through a third-party independent review. So Passive House Institute, we're an independent organization. We're not associated with any kind of other association, so we're not subject to anybody's agenda, so there's no fake news here. Advertisement of your product through the component database, so we're shining a spotlight on the highest quality components through our online database, which I'll show you in a moment. And providing great value for money. So, of course, we like to. Every company likes to think they're competitive. Of course, we're no exception. And I'll give you some information on how our fees are broken down later on in the talk. So, what are the benefits from the point of view of the designer? So, confidence, first of all, that the values are on the safe side. So those who work a lot with passive houses and in building physics know that there are values and there are values. It sometimes takes a lot of work to transform declared values into design values. All of this stuff is built into our certifications, all taken into account. Immediate acceptance of values in building certification. So if you're going ahead with certifying your construction product as a passive house, then you will need little to no further information if you're using passive house components, at least with regards to that part of the project. And we have a wide range of available products. So hopefully you will find something to fit your design vision and budget on our database. So for example, with Windows, we have the full range from low-cost PVC windows to very high-quality wood aluminium windows. So you will hopefully find what you want. So these are to be found on our component database at database.passivehouse.com. If you are on a double screen, maybe you can log on right now and start exploring if you're not familiar with it already. And if you do, you will find this map, which shows where our component manufacturers are based, and also what components can be delivered to which countries. So the dark red symbols are showing the components, the component manufacturers, where they're located, and the purple symbols are showing what components can be delivered to that country. And at present, there are just over 1,000 certified passive house components. As of December 2020, I think we're at 1,030 certificates. Could be wrong, maybe more and more of today, you never know. And these are divided up as like this. So you can see about a quarter of our components are windows, just over 1/5 are small ventilation systems, so the kind of domestic ventilation systems you would find in houses. And next come construction systems, large ventilation units, curtain wall systems, entrance doors, all the way down to sort of slightly niche products like flue gas heat recovery, wastewater heat recovery, balcony connections, etc. And these are also further divided up by climate zone, of which there are 7 passive house climate zones, from Arctic to very hot. So, for example, a window that was developed for use in Spain might not be suitable for use in the far north of Sweden. So our component seal will show which climate zone the product has been developed for. And in some cases, this will also include an efficiency class. For example, for windows, the narrower the frame of the window and the better the overall thermal performance, the higher the efficiency class awarded. And this is because of the increased potential for solar gain and the following reduction in space heating demand, etc. So you get the idea. And I'm happy to say that even during a pandemic, we are on an upward trend in terms of certified products. So you can see that 2020 has certainly not been our best year, but it has been our second best year, which is something we're really, really happy about, of course. And of course, there are still a few more weeks to go in 2020, so you never know, we might be able to push it up a little bit further. So how does the process of certification actually work? Well, of course, this varies widely according to the component in question. But generally speaking, this starts with the manufacturer providing us with their ideas and designs or specifications. And then we will carry out some kind of evaluation. This can range from simple checking of third-party test data. In the case of, for example, ventilation systems, these get tested in much larger laboratories. To carrying out of software-based simulations, which is what we do for mostly for Windows and construction systems, for example, to also physical testing in our own laboratory, which is what we do, for example, for air tightness systems. We actually perform the tests ourselves. And then we compare the results against our criteria. And if the criteria are met, then the component is certified. If not, then we'll make suggestions for the manufacturer for improvement, and then the whole cycle starts again. And I've written here that it can be done in as little as a week. That is true, for example, for a simple window. For more complex products, it might be many cycles. And in some cases, it might take up to more than a year. But where there's a will, there's a way, and in general, every request has led to a successful certification. So what is it that's actually checked, or what is analyzed? So for example, in the case of Windows, it's a case of looking at the thermal conductivities of the components that go into the window, transforming these from declared lambda values into rated lambda values in the case of proprietary products, where they or for example, taking the values from ISO 10456 for those who are familiar with that standard. We carry out FEM thermal modeling to the appropriate ISO 10211, and then calculation to the Windows standard ISO 10077 Part 2 to find out our UW value. For some components, for some transparent components, we also require additional testing. For example, for entrance doors, we require air tightness testing. Also for Windows systems, for example, we would ask for driving rain testing, wind deflection testing. Yes. So for construction systems, it's a similar process, checking of design details to make sure that there's a robust air tightness strategy, which is, as many of you will know, is a real fundamental part of achieving the Passive House standard. Again, FEM thermal modeling. In this case, for construction systems, there has to be a particular U value and hygiene criterion, met hygiene being the relating to the minimal surface temperature on the inside of the system. And of course, it has to be thermal bridge free. So psi value or linear heat loss coefficient of less than 0.01 watts per meter in Kelvin. For HVAC systems, as I mentioned, it's generally a review of third-party test data and comparison of the results against our criteria for comfort, so supply air temperature, for heat recovery and electrical efficiency, for air tightness, and in the case of, for example, a Passive House compact unit that also includes water heating, water heating efficiency. So if you want to take a look at our certification criteria, you are most welcome to do so. You will find them if you follow the screenshot that I've given on this slide. So if you go onto our website, www.passive.de, go to certification components and then certification criteria, you will find 15 criteria documents, not 16. The 16th is the air source heat pump criteria document, and we provide that on request simply because it's updated quite frequently, and we like to make sure that any interested manufacturers are looking at the latest version. Okay, so let's take a little tour through some of our certification criteria. We'll look first of all at transparent components. This was last updated in 2019. It's also available, of course, in German, also Spanish, thanks to Soraya's tireless translation work. And the heart of this document is the table 1, which shows the adequate certification criteria, namely the component U value, the UW value of the window at a certain size. For Windows, we use a reference size of 1.23 by 1.48 meters. The installed U value, so including the effect of the installation thermal bridges, the FRSI value, or the hygiene criterion, so based on the minimum surface temperature, and lastly, the reference glazing used. So if we take the example of a window produced for the cool temperate climate, so for example, Germany or the British Isles or much of the northern states of North America, of the United States, sorry, then these values would be the hygiene criterion or FRSI value of 0.7, the component U value 0.8 watts per meter squared in Kelvin, the UW installed 0.85, so a surcharge of or a supplement of 0.05 watts per square meter in Kelvin to take into account the installation thermal bridges, and then reference glazing of 0.7. So those of you who work a lot with Windows will know that that's quite a poor value for triple glazing in this particular region. That's deliberate because we want to promote the development of high quality frames rather than just standard quality frames that use very good glazing. That's also another approach, of course. Also important is the table 3, which shows the parts of the windows that are considered in the certification. Also lists all of the transparent component certifications that we offer, of course. So for a typical standard window frame, you can see that the bottom, top, and side profiles go into the calculation. This is why they're highlighted in green. And either one of the typical mullion types is included for information. You can see on the right-hand side under additional specifications where we sometimes require additional information. So you can see for a Windows system, air tightness testing, also for the entrance door, CE labeling. This refers to the driving rain testing and wind deflection testing that I mentioned earlier. Okay, so if we do the same thing for opaque construction systems, this was last updated very recently in September of this year. Again, the heart of the document is the table showing the required performance data. So for the cool temperate climate, in this case, the requirements would be, again, we have the hygiene criterion for all details, also transparent details, where the construction system is meeting where the window is installed. U value of the installed window, again, this is the same criterion as earlier. U value of the exterior building component, many of you will be familiar with this criteria 0.15, pretty typical passive house criteria for external walls, windows, and floors. We also have a hygiene criterion of purely opaque details, as increased FRSI value. Absence of thermal bridges, of course, and we added this year our moisture criteria. So this is based on a glazer analysis. This is something we will be looking to carry out with our new condensation tool, developed by my colleague Roberto Ionetti. And this is the criterion being evaporation of all condensation at the end of 12 months, so you don't get accumulation over years of moisture in air construction. And we also have an MA limit, moisture accumulation limit, of 200 grams per square meter. So this is regarding the surface accumulation of moisture to make sure that there's no runoff that would end up in the component getting wet. The document also lists, of course, the connection details that are taken into account, also in Table 2, in the form of hopefully clear diagrams of what is meant by each designation. So, again, lastly, let's have a look at the criteria document. In this case, just for small ventilation systems I'm going to cover tonight. Like I said, HVAC is a whole other world. Many different products fall under that category, but we're just going to have a look at this product this evening. So, for example, yes, small ventilation systems, meaning less than 600 cubic meters per hour of air exchange. Again, we have our table of performance criteria regarding minimum supply air temperature, the comfort criterion, efficiency criterion, heat recovery and electrical efficiency, balancing and controllability of the system, sound attenuation, hygiene, so what filter class needs to go into the unit, and frost protection in the case of a failure of the extract air fan or frost protection heater coil. So having looked at that, let's have a look at some of the deliverables from certified products. In this case, this is the Smart Win window from Paul Passive House Fenster. who have given me their permission for me to show you these very kindly. So here are the results of the FEM modeling of the bottom frame. So on the left-hand side, you can see the UF value calculation. In the middle, the glazing edge psi value calculation, and on the right-hand side, the temperature factor model. So I don't know, I can't see it very well. It's very small on my screen, but you can see that we're on the right side of the temperature factor 0.72. These results are summarized in a table showing the values and the subsequently calculated UW and UW installed values. These are the values that go then into the certificate. So these are summarized on the front page. And then inside, it provides details like the installation psi values. So here you can see how we test each window in 3 different passive house wall types. So always including an EIFS wall, so exterior insulation finishing system wall, but also usually lightweight timber and concrete formwork. But that's up to the manufacturer to decide. They can also provide us with their own installation details if they want. So here an example of extracts from a report for a construction system, actually from the same manufacturer, from Passive House Fenster, their smart shell system. You can see that the calculations are generally a mix of 3-dimensional and 2-dimensional calculations using the finite element method approach. The values once again being summarized on the certificate, but this time on the inside. So along with descriptions of the system, the air tightness strategy, what windows were used in the calculation, for example, the psi value and FRSI values are then summarized on the diagrams, as well as the installed UW values for the windows. In this case, you can see 2 different windows were used, so 2 different UW installed values. Lastly, let's take a look at an example ventilation system calculation. So again, small ventilation system. So domestic system. Yep, once again. The certified values are summarized on the first page, and then more detail given on the following pages. So here you get a lot of information. So we've got our humidity recovery information. Yeah, because it's a system that includes humidity recovery indeed. Comfort, supply air temperature, efficiency, heat recovery efficiency, and electrical efficiency, leakage, air leakage of the system, again, acoustic attenuation, balanced operation, and frost protection. So the hopefully not million-dollar question, how much does a certification cost? Well, our fees are broken down in all cases into analysis and certification. The latter is fixed. Generally speaking, per certificate, it is, at least at the moment, 1,214 euros per year. For some more complex systems, it will be more, but we also give discounts for subsequent certificates of the same type. So if you're a manufacturer who has, for example, 4 different variants of a window, we would charge you the full fee for the first window and then give discounts for each subsequent window. If you are interested indeed, please feel free to give us to get in touch. This is our email address, components@passive.de. The analysis fees vary widely according to the effort that's needed to carry out the evaluations that we need to carry out. But for example, construction systems, the influencing factors would be the number of details to be considered. We have a minimum number of details, but actually, well, not so much a maximum number of details, but there would be the details that would need to be taken into account in the PHPP. The number of 3-dimensional details will play a big role because these are much more complex calculations, and whether or not any kind of preparatory work has been carried out. So for windows, for example, if any calculations have been carried out in advance, then we can see on our first assessment that it's likely that the window will meet the Passive House standard, and we're not likely to need to include any consulting hours, for example. So, as the last part of this presentation, let's take a look at some certified components from manufacturers around the world. So if we go back once again to our world map from the component database, and if we were to go to Canada and look at components from Canadian manufacturers, we'd find, among others, Westcon Cedar Products in British Columbia, also known as Fenstur, who have certified 5 systems with us, so 2 window systems and 3 door systems, all very beautiful, extremely high quality timber frames. They also do timber aluminium, wood aluminium frames. If we were to go to Austria and look at Austrian manufacturers, we would find, for example, On the left here, this is a passive house compact unit from J. Pichler GmbH in Klagenfurt. So this is including heat recovery ventilation, a heat pump, and hot water provision. So it's a very space-efficient unit. On the right, this is a construction system from Isorspan. This is a woodcrete system. So it's a kind of Lego brick style concrete to be filled with concrete formwork system. If we were to go back across the Atlantic to the USA, we would find on the left, this is the Build Smart system. These guys are based in Lawrence, Kansas. So this is a lightweight timber construction system. On the right, a PVC window from Intus in Fairfax, Virginia. This is the Supera 83 window. You can see, if you look at the profile, you can see this is a warm temperate suitable window. So rather than being the typical passive house cool temperate window would be insulated, but this actually includes a lot of chambers rather than sections of insulation. So then if we go back to my home country, the UK, we'll see on the left-hand side here the BT Passive lightweight timber construction system, quite widely used. Then on the right-hand side, the Frame Ultra system from Frame Homes in the southwest of England. And lastly, let's go back to Germany, where it all began. You can see on the left here a typical exterior insulation finishing system from DAW here in Hesse. This is called the Alseco Passive House system. On the right, the C87 window from Tim Fensterbau in Berlin. And finally, just because they're super interesting, and actually just to note, the top one is from Austria, not from Germany. These are decentral ventilation systems, so these are designed to be installed either per room or, for example, in a small dwelling unit. The first is from Drexel and Weiss, designed specifically for classrooms in schools, so for quite high occupancy spaces. And this unit is performing extract and supply ventilation at the same time. The second unit is from Glen Dimplex and this is in German it's called a Pendellüfter, a shuttle ventilator or ventilation system. So you have two of these systems, and they would be, for example, at either end of a dwelling unit or either end of a corridor, a stairwell or something like that. And they talk to each other and they change direction at intervals. So you have a regenerative core in the middle of some kind of hard mineral that warms up with the extract air going out and then heats up the incoming air when it changes direction. So a pretty clever device. And that's it for now, at least with regards to the presentation. So thank you very much for your attention. Please feel free to drop me or drop us an email at components@passive.de. Inquiries about component certification or just any questions about component certification in general, very happy to help. You can also find further information on our database.passivehouse.com. Also, please feel free to take a look around our website, passivehouse.com, the knowledge portal, passivepedia.org, or the iPHA website, passivehouse-international.org. And once again, you can contact the iPHA team, info@passivehouse-international.org. Okay.
So we're just going to play a quick video from iPHA. So if you've got any questions to add into the chat, please take this opportunity, and there'll be time after, of course, but it might be a nice time. So just play a quick video to explain what iPHA gets up to, and then we'll start the Q&A. Okay, and welcome back, everybody. Thank you very much to Ed for your insightful and interesting presentation. We've had quite a few questions so far.
Oh, great.
And also some very positive feedback from Chris saying that he can certainly vouch for the window and door subcomponent certification program. It has always been a positive working experience with PHI on the certification process since we started in 2013.
Oh, well, that's wonderful feedback. Thank you very much.
So we have had a few of the questions answered in the comments, but lest somebody not have seen that, I will go back through. So Steve Mann asked what FEM stands for.
FEM is finite element method. This is a approach. So when working out the thermal values of, well, let's take the example of window frames. There are generally three approaches using tables. So from standard documents, you can do an FEM calculation to ISO 10211. This is a computer simulation where you basically create a two-dimensional, three-dimensional model that gets broken up into lots of little pieces, and thereby the heat flow measured through through whatever it is that you're modeling. Or you can do a hotbox measurement, so that's actually going into a lab and taking a sample and measuring the heat flow through the unit. Actually, FEM calculation is one of the most, you could argue that it's the most accurate because if you did a hotbox calculation, it can include some kind of irregularity. So if you're using something made out of timber is very irregular. It includes a lot of knots, its thermal conductivity is quite different across the material. So if you use the standard thermal conductivities that we use in FEM calculation, those are based on conservative values for those types of materials. Am I making any sense? Does that answer the question?
I believe so.
Yeah, finite element method, that's what it is.
Thank you for the explanation. We have a question from Vasilis asking why air tightness and water tightness is not clearly stated on the certificate. Are there targets for air tightness performance, for instance?
Yes, there are targets for air tightness performance, and I can't think of it off the top of my head. But if you go into into our criteria document, you will see on the right-hand side. If we're talking specifically about transparent components here, it's different according to the component type. So for a window, it's going to be a certain amount of leakage per meter of the joint of the window at a certain pressure differential. So I think it's 100 pascals pressure differential. And it's also different, again, for doors. So, and those are, in terms of air tightness, at least that's something that is in door certification, that is absolutely a requirement. For Windows, it's only for Windows system certification. So where we are certifying both the openable and the fixed window with all of the all possible transients and mullions that go into it. So yes, so please have a look at our criteria document. It's all listed there.
And we have included a link to the site and the specific page where you can find all of the different certification documents for different components. So we have another question from, just moving up the list, from Ryan. Can you discuss the process of component certification for a volumetric modular project versus certifying it as a building a bit more?
Okay, so I understand from this, are we talking here about a prefabricated modular house? I think that's what I'm understanding here. So if I'm wrong, then please write in the chat that I'm wrong. And this is it's a tricky one, and it's one that comes up again and again. And essentially, there's no problem with modular construction system certification. It just tends to be that modular buildings are quite small. So if we're talking, especially, it's kind of fashionable in recent years, the whole kind of tiny house movement. And we've had a few inquiries about certification of tiny house construction systems, which is fine. That would be great. We'd love to do it. But in terms of meeting the Passive House standard, the smaller the building, the more difficult it is to meet the efficiency standards. So the space heating standard, PER standards that are required, because you increase the heat loss area ratio in comparison to the volume of the building, which means you theoretically need to add more and more insulation to get the same effect. So when we've been approached by manufacturers who are looking to certify their small building modular construction systems, we've also suggested that we carry out a further analysis using Design PH and PHPP to see if, using their construction system and even with the values that we've modeled, if it's possible then to achieve the Passive House standard. So Passive House standard is much easier to achieve with, well, what we would call standard-sized single-family homes, if they're single-family homes, or multi-family apartment buildings. The larger the building, the easier it gets, basically. Yeah. That answers the question.
I believe so. Ryan did confirm that was exactly what he was talking about, and perhaps he'll write back to let us know if that answered his question. Okay. Chris has a question. Are there any major changes in the certification processes and parameters, particularly in window and door systems in 2021?
No. Short answer. No major changes coming up. The only major change that's happened recently is to do with the construction system certification criteria, and that was to do with addition of the moisture criteria, because it's so important when it comes to durability of construction systems. So yes, I hope that answers your question. No major changes coming up.
Very succinct. Paul asks, you gave a cost for annual certification fees, but not for the full assessment. What range of figures for a window certification can be expected, for example?
For example, for a window, we're talking, I don't want to give an exact figure because I'll get in trouble, but we're talking in the realm of, in euros, we're talking about €3,000 to €1,000 mark for a standard window certification that includes 2 profiles, so the bottom profile and the top side profile, the U profile, and a mullion, and then 6 installations, so the bottom and the top/side, the installation in 3 different wall types. So then it gets much more complicated if we're talking about like construction systems or window systems, because these are many more details that go into that, and of course the time that takes to do the certification is much longer, so we have to charge more for it.
Okay, so we're talking about the time investment is really where that costing is coming from.
Exactly. We always base it on how long we think it's going to take to do it. So yeah, like any engineering company, I guess.
Excellent. And then Vasilis has another question. Is there any chance in the future that we'll see embodied carbon targets for components and products? How about, for example, windows?
It's a really good question. At the moment, and for those who work with the Passive House standards already, you will know the Passive House standard is about the energy in operation. We do not consider embodied energy in our calculations at the moment. It's something that is frequently discussed. We are very well aware that there are certain components or certain materials are more energy intensive and have a greater environmental impact than others. And this is something that is, of course, of great importance. It's just that this is also something, an area of development for us. And it may be the case, I don't know, but for example, it may be the case that our system of evaluation will dovetail with another system, as it does with, at the moment, Passive House dovetails, for example, with LEED certification. So LEED being a much broader sustainability certification in comparison to Passive House, which is just to do with the operational energy demand. And of course, all of the other things that go into a LEED certification, like water use and daylighting analysis, I think that goes into visual comfort. That rings a bell. It could be that Passive House then dovetails with another certification or evaluation system that looks at embodied energy demand. But yeah, at the minute, we're about operational energy in use.
Embodied energy is definitely on the agenda at PHI, and it is a topic, as Ed said, that is in development and will be researched and looked into further in the coming years. Vasilis has rephrased his question to, is it likely for certified components to submit the LCA first?
The life cycle analysis. Yeah, that's... I can't comment. I can't comment. Yeah, I can't comment because I don't know yet. So sorry about that.
All right. Then Richard Walklin has a question. I'm interested in why there are PVC windows allowed, given PVC is a product not endorsed, in fact, on the red list of the Living and Building Challenge and Declare labeling system.
Yeah, it's a very good point. And yeah, I mean, regarding everything that we just mentioned about environmental impacts of materials, yes, this is something that we want to look into more and more in the future. It's not something that is included in the Passive House standard at present, and also something that needs to be acknowledged is that PVC windows take up, I think it's about 50% of the market, maybe even more, is made up of PVC windows. It's a huge part of the market, and it's the largest part of the market because PVC windows are so cheap, or shall we say affordable. And when it comes to reduction of operational energy, actually PVC windows are very useful because it's quite easy to make PVC windows that are very energy efficient. So yeah, I completely take the point. Yes, and if we were looking at the environmental impact of PVC plastics, very difficult to recycle, for example, in terms of the manufacturing process, PVC tends to be insulated, or PVC windows tend to be insulated with petrochemical-based insulations. Yeah, absolutely, it is 100% true. But then there are, of course, arguments in favor of PVC windows as well, but generally to do with the operational energy demand of a building.
And Richard adds, health and safety, as well as the preservation of the environment, sorry, is very important. And of course, and that is why we look at the Passive House standard, for example, reduces operational emissions and energy demand. And of course, it is the building physics aspects. We don't prescribe a certain window, of course.
Yes.
That's why we have a range of different windows, for example, made of different materials.
Yes, thank you for saying that. Yes, exactly. The Passive House standard is a series of figures. Basically, it's the PHPP is one big energy balance modeling tool based on the Excel table, and it is simply to do with meeting those energy performance standards in terms of kilowatt hours ultimately. So yes, we don't prescribe how that should be met at the moment, and we don't necessarily reward or penalize any particular approach. Although, of course, it's great to hear of Passive House projects that are using approaches where materials are being used that do have either a very low embodied energy, low embodied carbon, or indeed are sequestering carbon. Which may be the case with certain types of timber construction, for example. And yeah, I mean, the most interesting to note is that we have a Passive House certified straw bale construction system that's it scores very well in terms of life cycle carbon analysis. Also, there's one particular company in Canada who uses rammed earth to build passive houses, which is a really interesting method of construction. It's a shame that they haven't approached us for component certification yet. It would be great to work with them. So yes, it's definitely possible to achieve the Passive House standard with using more kind of what you might say ecological approaches. So using materials with low embodied energy, low embodied carbon. Yeah.
Thank you. Do we have any other questions from the audience? While you are coming up with them, I'll ask Ed a question from iPHA. What is your favorite part of component certification?
My favorite part of component certification. My favorite part. I really enjoy the FEM modeling, the finite element method modeling. It's really interesting, and it's because there's no I mean, you can look at a window frame and you can have a rough idea of how it's going to perform. And then but then sometimes it's a bit of a surprise when the details come out and you think, oh, it performs a lot better or a lot worse than I thought it would. And you get to look into the things that make a real difference to the energy performance of a particular product. So yeah, it's kind of like, it's a bit like do a little kind of puzzle when you do it and you finally get the results. It's either good news or it means a little bit more work, and yeah, that's it. It makes it fun.
Good news or back to the drawing board?
Yeah, exactly.
Clyde asks, what was the building system you just mentioned after straw bale? Rammed earth.
It's not a
building.
It's not a building system. Well, it's a method of building. It's not a certified construction system. And I can't think of the lady's name. Can you think of her, Georgia? I think she's in Ontario, and she comes to pretty much every conference. I forget, but she is she's the Rammed Earth lady, and she works with Rammed Earth houses, and it's great. I mean, anybody who's been in a Rammed Earth building will know what a in terms of qualitatively, it's a fantastic space to be in. I mean, it's really has a real warmth to it, and acoustically, it works in an interesting way as well. So yeah, Rammed Earth is what we were talking about.
Perhaps the Canadians who are with us tonight can.
Yes, any Canadians? Can you mention
in the chat box?
Yeah.
Paul Malian asks, is it down to designers to choose sustainable materials? Oh, it is. It's not a question. Mm-hmm. It is down to designers to choose sustainable materials, not the Passive House Institute. There are plenty of sustainable options out there. And honestly, we at iPHA get to see all of the new innovative projects and promote them. And it's really amazing to see what's coming out of countries all over the world. There's lots of new Passive House wood constructions. There's lots of new innovative ways to retrofit with sustainable or recycled materials. So we're always really excited by that too. Yeah. Keep coming up with the great ideas.
Yep. Terrell Wong, that's who I meant.
Excellent. Then Richard says, I suggest there's a great opportunity for Passive House Institute to adopt a new approach on this subject due to many governments around the world which are declaring a climate emergency. What is Passive House doing in this space? Perhaps that's more my area. So the International Passive House Association is very, very active in policy guidance and advocacy work. We work with a lot of different committees from all over the world, the Global Alliance for Building and Construction, the Cool Coalition, and so many more. We do a lot of work. We sent Ed last year to Armenia to give some training for the UN ECE. So we do a lot of work there. We do a lot of capacity building. We do a lot of advocacy work, and we definitely try to teach and promote best practices and lessons learned that we obviously come into contact with through our worldwide community who bring us the solutions that they have found, and we obviously share any updates and news and research from the Institute in return. So we really are a global community who are sharing that information and that learning and bringing it then to these governments who are declaring climate emergencies, so that in our own way, in the building way, in the operational emissions and solutions for that, we can put forward better paths to deal with the climate emergency. Yeah. Steve Mann asks, do you use Flixo for your FEM modelling?
We do use Flixo, version 8.1.
Excellent, yes. Very succinct.
Just to mention, actually, good time to mention, you do not need to use Flixo. Flixo is simply FEM software. ISO 10211 has a whole section on calibration of FEM software, and any FEM software that meets those calibration standards can be used for thermal bridging calculation, basically. And we worked last year. All my years of version to, I don't know, this year feels like it was a decade long. I think it was last year we worked with RDH in Vancouver in Canada to develop a document that outlines the whole approach to modeling of passive house windows using Therm. So anybody who's familiar with FEM software will be familiar with them. It's kind of the industry standard. It's what's the word, open source from UC Berkeley, and is also a really user-friendly software. You can also import. The most important thing for me is that you can manipulate your drawings in an AutoCAD or a CAD program and then import them into the software, and you can do that with them. So it's just that Flixo is really, it's very good for reporting, which is something that we do all the time. So actually, and it's quite an expensive software, so it's quite a big investment, but it's worth it for us because we use it on a commercial basis. But Therm is just as, in terms of the building physics, Therm is just as good. Yeah.
And I think that killed two birds with one stone. Vasilis had a similar question asking about the software that you use. Yeah. We currently don't have any other questions from the audience, so if you have any others, there's still a few minutes to go.
Yeah.
And Ed, what has been your biggest achievement in component certification over the past 5 years?
Oh, my biggest achievement. I can think of one or two really, let's call them sticky certifications that were just not easy to resolve because they included a lot of very complex geometry. That meant it was a lot of maths. So a lot of doing three-dimensional models to create equivalent thermal conductivities that then can go into two-dimensional models from them, which we can then create or generate the values that we need. Those are the kinds of products where at the end you really you want to crack open a bottle of Prosecco and put your feet up, and it feels like a job well done. I mean, especially if it resulted in the project being certified, which what I'm thinking of this one was. So those are my I suppose my proudest moments, and I have highlights like when I get to talk about competification to people who want to hear about it, which is always wonderful, and yeah, get to go on interesting trips. It's always fun. Yeah.
Excellent. And Steve has a question asking about software. What do you use for your 3D modeling?
We use a combination of, we use something called has a terrible name. You can tell it's German from the name. It's called iPHA, iPHA, from a German producer, but it's essentially an AutoCAD clone, I suppose you'd want to call it. I mean, AutoCAD is of course very expensive. So, and if you can do three-dimensional modeling with quite a simple CAD program, but we also use we have one AutoCAD license because we need to be able to produce STL files, which is what goes into the three-dimensional modeling software, which for us is Solido. But again, Solido, we simply use Solido because it's user-friendly, but there are many softwares that are calibrated to the same standard and that can be used for three-dimensional modeling. It's just simply our preference. Yeah.
Excellent. And we see Louise has added a document from Passive House Canada on the British Columbian reference procedure for PHI.
Thank you very much. Yeah, that's the one I was referring to, exactly.
Excellent. And many of our affiliates from around the world have localized documents that might help if you are in a country that is not Germany or wasn't mentioned today, and they can help you along with starting the procedure on component certification and asking where that process goes. So do get in touch with us if you're wondering if you have any local partners that you can get in touch with, or of course, as Ed had mentioned in his presentation, you can contact the Component Certification Department directly. So, are there any final questions? I see Richard has noted that SketchUp is also good.
SketchUp is also good. SketchUp is also compatible, or you can use our Design PH plugin. That's to do with energy balance modeling of a building on the large scale. But yes, that also includes our list of certified components.
Wonderful. Then, thank you to everyone for joining us this evening. We hope you had a wonderful night and that you learnt something new. If you do have any questions, as I mentioned, do get in touch with us and do make sure that you collect those points to recertify. The code can be found in the PowerPoint that was at the start of the presentation today, or you can find it, as I mentioned, on the trainings department's website. We'll have a few more Q&A sessions coming up from the training department and of course also the tools department, so you can learn a bit more about what they get up to as well, and that should get 2021 off to a good start. So that is it for Q&As for 2020, but we hope that you have a really wonderful holidays and a happy new year, and we cannot wait to continue these iPHA Q&As with PHI in 2021.